Aren't we fascinated about bubbles? Don't we like blowing and chasing the bubbles? Today we are going to make bubble snake and learn the science behind the bubbles. Welcome to Merrymoppetsguild, fun and exciting STEAM learning lab. Today's experiment is to know how to make bubble snake. For this experiment we need a plastic bottle, old socks, a bowl, glass of water and some dish soap. We have to take the bottle, cut the lower part of the bottle. Please make sure you are doing it with the adult supervision. Cut the bottom part of the bottle with a sharp knife or scissors. Take one old sock. Pull the sock. Like this into the bottle. Now take the dish soap, pour approximately 2 tablespoons into the dish. Lots of it, isn't it? That makes good bubbles. Pour approximately 200 ml of water. And mix it really well. The fun part begins. Dip the sock end into the bowl where we have made the soap solution. And blow it from the other end of the bottle. Wow, what a long snake it is. So lovely. Lovely bubble snake. Lots of fun, isn't it, children? Okay, now what is a bubble? A bubble is actually a pocket of air surrounded by a thin layer of liquid. The bubble is actually made of 3 thin layers. First layer is made of soap, the second layer is made of water and the third layer is another layer of soap. The sandwich that is on the outside of the bubble is called a soap film. The air is filled inside the bubble and the first layer will be the soapy layer. The second layer will be of water and the third thin layer again will be soapy layer. And the air is filled inside the bubble. So it looks like a sandwich of soapy layer, soap, water and soap. Now we came to know what is a bubble. We should also know how are bubbles formed. Water is made up of lots of tiny molecules. The molecules are attached to each other. The molecules are attached to each other and they stick together. The molecules on the very top of water, stick together very closely to make a force called surface tension. This force of surface tension is also responsible to create bubbles. In plain water, the surface tension is very strong and the water might make only some bubbles. You would have noticed if you just shake the water with your fingers, you might see very small bubbles. But have you also noticed that those bubbles will not last for long? Why? This is because the other water molecules in the water will pull on the bubbles and they flatten. Now, we are adding soap to the water and we are making a soap solution. The water becomes flexible like an elastic now. The soap, when added to the water, lowers the surface tension so that the bubbles can form. Are you able to understand that? Wait. Now when we add soap to the water, the molecules inside the water are pulled apart. So that makes water molecules flexible. The molecules in the soap increases the distance between the water molecules and reduces the ability of water molecules interaction with each other. When the attraction between the water molecules decreases, the surface tension of the solution is lowered considerably. So, when air is blown into the bubble, it can hold the shape and it is flexible. Do you notice? The bubbles are popping. Why? We saw how to make bubbles with soap and water, and also we all know water evaporates. The water in the bubble is a sandwich between soap layers. So the water inside the bubble evaporates in the dry air. So the bubble can last as long as the water lasts. Do you think that's the only reason for a bubble to pop? What's happening? When something sharp or dry touches the bubble, a hole is formed in the bubble skin, allowing the air to escape and pop. Now, there is some pressure inside the bubble. The pressure of air inside the bubble is more than the air outside it, and that's why when the bubble burst, we could hear the pop sound. Can you hear the pop sound? Children, why are bubbles round? I'm sure you would have tried blowing bubbles from different shapes of wand. Whatever the shape of the wand is, you will finally see the bubbles round. Why is that so? Do you remember the sandwich layer we are talking? And the surface tension? Even though the soap helps the water spread out into a bubble by making the particles in the water less attracted to each other, they still get attracted to each other. Now let's think the wand is of this shape, okay? And the water molecules, when we blow the air to form a bubble, will be in this shape. A sandwich layer of soap, water and soap. When the water particles pull on each other around the air inside, they give the bubble its round shape. the water particles always get attracted to each other, and that is why they form a round shape again. So, even if our wand has corners like this, the attraction in the particles that make up water pull those corners out and give us a nice round bubble every time. Children, please make sure that you are blowing out and not you are sucking. You should not suck it inside. Be careful with that. Let's have fun with bubbles, but we should always keep the science behind it in our mind. Thank you, children.